As an example that's just slightly more complicated, let's suppose we want to track positions on the screen and do various things with them. Now, position on the screen is down a certain amount and over a certain amount, so a single integer will not be convenient for representing a position. Instead, we want two integers put together. And to do that, we can introduce our own type, capital P posin, with just one way to make a posin, which is to put an x and a y integer together using lowercase posin. And let's suppose, just to have something to do, that what we want to do is flip a position over the diagonal. So swap the x and y parts of the position. That was our representation step. We figured out that we want two integers together, and so we introduced a new type posin. The next step is examples. So let's consider what happens when we call flip on a posin. So we have to use check, we have to use flip, but now our work from the representation step says you need to figure out a posin to pass in. What is posin? Well, we have the type definition here that says you can construct it with the posin constructor. So we'll use that, and we get to pick two integers, x and y. So I picked 1 and 17 here. If I flip over the diagonal, that means swapping the x and y components, I should get back a posin that has 17 and 1. We can write some more examples, like maybe I throw in some negative numbers because we didn't disallow that, and considering the examples, it makes sense. So I'll use a negative number in there too. In this case, maybe that's enough examples because we only have one way of making posins. There was only one way to make that choice, and there isn't really any boundary condition that's of interest here. So that would conclude our example step. Next step is a template, and this is where the template starts to do a little more for us, because we know that when we write a flip function, we will get a posin in as input. And we know that in every posin, we have an x field and a y field. So the template encourages us to write down not just that we have a posin p, but also pull out the pieces posin x and posin y. This is one way to remind ourselves that we have x and y to work with. Another way to write this function would be to use match and pattern matching, where we cover all the possible cases, which is just one with posin, and we have a x and y field to work with in producing the answer. I'll go with that second version. They're equivalent, but this will turn out to be easier in the long run. And now I'll finish up the body step. Remember, we go look at our examples that we have from the previous step. Consider what happens in this first example. We have a call to flip. P stands for this posin 117. That means in the match setup, x is going to correspond to 1 and y is corresponding to 17. So we've got a 1 and a 17 here. We're trying to get posin 17, 1. So all we need to do is swap the x and y around and then wrap them with posin, some parentheses and a comma. So again, this posin would go in, get matched into x and y, we would put them back together to get 17, 1, that test case passes. Considering the other example here as a test case, then it also works. And so when we run these tests, it's going to pass and we'll be done with this function.